don't worry. So the last board which I want to cover is the AS-Path, and why I am covering it right now here is because we know about this AS-Path attribute, right? And actually, if I traverse the path of this route, which is 7.7.7.0, and which you all have been doing, right? This route is going to be here, here, and eventually to the R6. And R6, I am giving this command, show IB BGP. So it is showcasing me this path, 400, 100, 500, and 700. It means that route was generated in 700. It traversed to 500, then it passes through 100 and passes through 400 and then reach to AS600. It is as simple as that. So this is the actually AS path attribute which can go from one router to another router. No problems, right? And every autonomous system, when it advertises the route to different autonomous system, it is going to append its own AS number. We all know about it. And why this attribute was used? The number one reason was to avoid the loop, right? If in a particular update I see my own autonomous system number, then I come then of course I know that this route have already been passed to me, and that is why I am going to discard it. We have talked about it, right? So this path attribute is actually your loop avoidance algorithm, sorry, loop avoidance technique in BGP. But what else? What else it does? Actually, it also used in your traffic engineering. So guys, whatever we were doing in last board, that were traffic engineering, right? We have decided that everything should go via R1. This is the traffic engineering we have done, right? We have moved the traffic in according to our need, and that is what we know as traffic engineering, right? We can change the path of the traffic in accordance with our need, right? So what is happening here, guys? Actually, now suppose I have another AS number here, maybe, which is say AS1500, and the route inside this AS1500 is 15.15.15.0/24. What I want to do now is this route is actually advertised here, here, and of course it will be here. It will be in AS100, and now I am interested in AS router R3 route. What it is going to receive? It is going to receive this path via two different next hop. The path number one is going to be 15.15.15.0/24 via R4. The second thing is 15.15.15.0/24 via R5. And of course, the attribute you can write down straight away here, that it is going to be 400, then 600, and of course 1500. And here also, this is going to be 500 because the path is from via R5, then 700, and the route taken birth in 1500. It is as simple as that. Now, what I'm presuming is I'm presuming all other parameters are same, means the next hop, first thing first, BGP is going to check whether the next hop is reachable or not for all these routes. If it is, then basically those are going to be installed, right? So if these route you can see into the IBGP table, then basically the next hop is reachable. It is as simple as that. The second thing I'm presuming is that the weight you haven't configured. It means that the weight is 0 for all these routes. So weight cannot be the deciding factor in selecting the best route. The third thing, it is going to be the local preference, and I am saying that is again the default, which is the default value is 100. It is also not the deciding factor. Then the fourth thing is actually on the basis of your AS path, you can decide. But my problem here is, can I decide on the basis of AS path which route is best? Try to understand from the left hand side. If I want to go out, I need to traverse number 1, number 2, and then basically eventually this number 3. So the AS path length is 3 from the left hand side, and again if I choose to go via this side, it is again 3. 500, 400, and then 1500. It is as simple as that, right? So can I take the decision on the basis of AS-Path? No, right? But can I tweak AS-Path so that I can change it? Now, Mr. Prashant Patil again is going to its network engineer and he is saying, Mr. Network Engineer, I do not want you to configure wait, local preference. Can you do this traffic engineering so that I can always go out from this time? Let's change a little bit. That my AS100 should always go out from this side to reach 15.15.15.0 network. And now Mr. Network Engineer is thinking aloud that yes, we can do that. So what Mr. Network Engineer is doing, whenever it receives a route from R5, which is that route? This route 15.15.15.0/24 via R5. It says I can increase the AS path length. Right now, the length of the AS path is 3. Why? Because this is the first AS number, this is the second AS number, and this is the third AS number. I need to pass through 3 AS numbers, right? In both route 1 as well as route 2. And that is why the AS path length is 3. Can I change it to 4 or 5 or 6? And absolutely we can. So from R2 side via R5 the AS path length is 3, 500, 700 and 1500. You all know that. So now Mr. Network Engineer is doing that whenever it receives this route 15.15.15.0 from R4, it is going to increase its AS path length from here. Interesting, right? How to increase the AS path length? It's just a matter of command. But try to understand what we are doing here. We are doing here that whenever we receive a route from R4 in R1, we are going to increase this AS path. So the previously the AS path was only 1500 from where the route taken birth, then 400, then 600. And what I'm going to do is I am append another AS path here, or maybe twice. And it is safe to append your autonomous system number, which is AS100. So now what you have done, guys, whatever route you are receiving from R4, right, you have increased this AS path length. Now, if you see here, the AS path length of course, R1 is going to advertise in the BGP update, and R3 in the first route, along with having 400, 600, and 1500, it's going to have two more ASs, which is 100 and 100. It means that the AS path length of the first route is going to be 5. Why 5? Because now you have two AS path in terms of AS100, path 1, then 2, then 400, 600, and 1500. It is going to be 5. And for the second route via R5, you are having only 3. You haven't changed anything here. And that is why the BGP is going to select the best path on the basis of AS path if the previous parameters are same, weights are same, local preferences same, right? Then it is going to choose on the basis of AS path, which means it is going to choose route number 2 because it is having the lower AS path length, which is only 3. And that is why the traffic is going outbound direction like this. Simple, right? No issues. It means that AS path can again tweak your outbound direction. But believe me, this is a parameter which can influence your inbound routing too, or inbound traffic flow too. Right now, what is happening, guys? You are changing something in routes which are coming to you, and that is why it is impacting the traffic which is going out, right? Believe me, you can do. If you want to change the traffic direction, or if you want to play around with the traffic which is coming to you, then you need to change something which is going, you need to change in the route which are going out from you, right? And believe me, AS-Path can change your outbound direction. You can do the traffic engineering in outbound direction as well as inbound direction. How? Let's see that. I will take another 2 minutes of yours in explaining that, right? So this way, basically, you all comfortable about now that AS-Path can actually uh, tweak your outbound traffic. But let's see how it is going to tweak the inbound traffic. Suppose here R3 is going to have a specific route, suppose 3.3.3.3, and you are advertising this route from here as well as from here. And you always want that traffic from outside should reach to this guy R3 from R1. So what you are going to do is whenever you are advertising this route towards R5, what you will do that I am advertising this route 15.15.15.0 to you, Mr. Right? But I do not want that the traffic should come via you. So what I'll do is I will increase the AS path when I advertise it. So I will append maybe 2 or 3 AS paths here, right? And send it to you. So at R5, when you receive this route, it is going to be having AS path like this 100, 100, 100. Why 300? Because you are prepending it, because you are appending it in the beginning of the route, and you can do that using a simple command. Then basically it is going to be 500. Here, the AS path length is going to be 100, 100, 100, then 500 and 700, and then basically the traffic reaches here, and from here basically you are not appending, so this path is going to be shorter, right? And that is why this guy, now this autonomous system number, just try to understand, it is getting two paths. One is from 600, one is from 700, and the path from 600 is going to be shorter, and the reason is because you are not appending this direction, and that is why the traffic which is moving towards you will take the path from here, because this is the AS path. Now see the traffic direction, guys, it is towards you. It means that AS path is the attribute which can tweak your forward traffic as well as reverse traffic direction. It is as simple as that. Having said that, this is what I wanted to inform you in current in this topology, sorry, in this board or over class. If you have any question, please do ask. And Mr. Burak has the question. Mr. Burak, please do ask your question.
Okay, thank you, Ishna. This process or this kind of logic is called as AS-Path prepend,
Yeah,
right?
yes, AS path prepending. Because you are prepending here when you're moving out, right?
Okay, thank you.
Mr. Raj Sekran Prakash, your question now. Please do ask your question.
Yeah, maybe I'm wrong. Like I have a doubt, like which will take preference, like AD administrative distance or whatever we having this path selection
That
criteria.
will come later. But for now, basically, see, if you are learning a route from, see, AD will come into picture when you have two different sources of the route. Suppose you have a route 7.7.7.0, right? If you are learning the same route
Yeah,
in OSPF, the AD value is going to be 110. And if you are learning the same route in
yeah,
the BGP, specifically in the case of eBGP, the AD value is going to be 20. Then there is no doubt about it that basically BGP route is going to be preferred, right? So this is the case
okay,
when we have two different routing protocols. But yes, in case of IBGP, we have 200, and in case of eBGP, we have 20, right? And there is a specific reason to it. We'll talk about it. Do not worry about it, right? But try to understand
okay,
AD is used when you are learning the route from two different ways, to different sources. And if these are two different sources, then it is based on the admin distance value, which is whatever is a smaller is going to get the routing treatment preference. Sorry. Having said that,
oh,
let's go to
thank you.
the question of Mr. Prashant Patil. Prashant ji, please do ask your question.
Yeah, Vishnuji, could you please go back to the previous slide?
Absolutely, yeah.
Okay. Let's assume on R3 router, okay, towards R2, I have configured higher weight, okay,
Higher weight.
and on yeah, and on R1, I configured the higher local preference,
Okay.
okay. So if I do a trace route from R2,
Mm-hmm.
okay, towards 9.9 networks, which path it will select?
Okay, I'll tell you. It depends on basically where you have configured. So if I understood it correctly, what you are saying here is you have configured weight here on R3 or on R2?
Yes.
R3.
I configured weight on R3 towards R2, higher weight towards R2.
Towards R2 means basically whenever you get the route from R2, you are assigning the higher weight.
Yes.
And for what route you have done
Okay.
that? Suppose you have done that for 9.9.9.0, right? And I'm
Correct.
writing here
Yes.
9.9.9.0, right? /24, which is via R5. You have assigned the higher weight, maybe say 450, suppose, right? And now
Correct.
whatever the routes you are getting from R1 from this direction, right? You have assigned the higher
Yes.
local preference here.
Local.
So this is
Yes.
the weight and the local preference 9.9.9.0/24, which is via this time R4. You have assigned the local preference here, which is maybe 300, suppose, because these are two different things. This is the
Correct.
local preference, right? Which route is going to
Correct.
be installed, which is the best path. So
And
we will
yeah,
again choose.
if I do trace route,
If I
yeah,
again choose.
if I do a
Mhm.
mhm.
So from
If I
R3,
do a trace route from R to
from
R2,
R3, right?
uh,
From R3 you want to trace.
no, from R, no. If I want to do a trace route from R2 to network 9.9.9 network, in this scenario, which path it will select?
Okay, just try to understand. If you are doing a trace route from here, right? From here.
Yes.
Now, see, then we need to talk about the routing table of R2. Here we have written down the routing table of R3. In this case, of course, the weight is going to be taken the preference, right? This one. And if you are
Yes.
taking the 9.9.9 out from this R3, you will be seeing this as the traffic is going to go out via this one. If we talk about R3, but now you are more interested in R2. Let's talk about R2 now, right? It's my mistake that I understood it wrong. So let's talk about R2. We are writing the routing table of R2 here. And this is going to be very, very interesting case, right? Why? Because R3 is never ever going to advertise, and we are talking about the 9.9.9.0 route, right? So 9.9.9.0 route is advertised via R5 from here to here, right? With certain weight and certain local preference. Basically, when it goes to into R2, the weight is going to be 0 and the local preference is going to be by default, which is 100, right? It is as simple as that. So right now, if I tell you that R1 is going to advertise this route 9.9.9. towards R3, right? But my problem is because this is the IBGP pairing, R3 is not going to advertise it toward, because one IBGP learned route is not advertised to another, right? So for this, to understand this problem correctly, you need to create an IBGP pairing from here to here, true? Okay. Or you need to create this as
Okay.
a route reflector so I'm presuming that you have done those changes, and now this route is coming from R1 towards R3, and this route is going from R3 towards R2, the 9.9.0. Okay, it is learning the two routes. One is from R5, and now it is also learning the same route via R3, which is the IBGP pairing. Okay, now let's try to understand. Here basically at R1 you have configured the local preference, or at R3 you have configured the local preference, right? This local preference is transitive. It means that when R2 learns this route via from R3, it is going to say 9.9.9.0/24 via R4, and the local preference is going to be your 300. You get the point?
Yes.
Right? Because you have configured the local preference. Local preferences basically will travel along the route from here to here, right? Now you are going to have two routes in the R2 routing table. One is via this R3, which is actually via this R4, and the other route is going to be 9.9.9.0/24 via R5, and the local preference here is going to be 100 because you are not changing anything. You're getting my point, Mr. Prashantji?
Yes, yes,
Now,
yes.
on what basis we check? First, next hop. Next hop is reachable. I don't see a problem there. The second thing is weight. Weight is not a problem here because for everybody, for both of them, the weight is going to be 0 because weight, you are not sending from R3 towards R2. Weight cannot be sent, right? But the third thing is the local preference. Local preference of the route which is coming via R5 is by default 100, and the second thing is the route which is coming from R4, it is 300. So the path is going to be like this, and it is again very, very interesting. Suppose there is a host connecting here, it will go to R2, then it will go to R3 via R1, and then it will go like this. You're getting my point, Mr. Prashantji?
Yes, yes.
And this is actually what you will have in the looped topology, right? And that is why I given you the exercise, right? The first exercise which I gave you. It is very, very important. So, Satish ji, you have another question. Please do ask. This is going to be the last question of today's session because we have already way over the time. But yes, I could understand the session is very, very interesting, and that is why the questions are. Mr. Satish, your question now, quickly.
Yeah, this next slide,
Okay.
we append that AS number, local AS number, right? So, there is a first thing is we are not giving that local AS number in preference, right? When the route is going to transfer within the AS, and as well as it will not. The routers within that autonomous system, if they see that their own router number, it may drop that route as well, right?
Yeah.
So how that is going to working when we have appending that
Just try to
additional
that
AS?
is what, just try to understand. When we get this route, if we want to change the direction of outbound traffic, when we are getting this, right? The route number is 9.9.9.0, suppose, right? Which is coming somewhere from here.
Hmm.
The route doesn't comes with appending of 100, right? But you are saying here that when it comes, I will be appending 100 on top of it. You're getting my point? Okay.
Okay.
IBGP does not take decision on the basis of this, that this route is basically, it is coming, it is having my own autonomous system. No, this is the EBGP loop avoidance criteria. We do not have any loop avoidance criteria on the basis of autonomous system. Just try to understand. Although you are sending this route from R1 to R3, R3 is not going to see that, oh, it is having my own autonomous system, I will be dropping it. There is no such mechanism inside IBGP or inside your autonomous system number. This is for when you send route from here to here, okay? And now, suppose you want to prepend in exit direction. You can do that. Right now, you are sending only 100 by default. You are appending 2 more hundreds here. If it reaches here, no, it is not violating anything, right? You're getting my point, Mr. Satish?
Yeah. Yeah.
Perfect. Having said that, I think it was a great session because of your questions. See you tomorrow at the same time, 7:30 in the morning. Have a nice day ahead. Bye for now.